flip of a switch. Electricity to start a vacuum cleaner. Electricity toasts our bread and irons our clothes. It brings news and entertainment from the far right. It gives us light to read and work by, and it makes life more comfortable by operating the everyday machines we depend on so much. Because we use electricity all the time, we hardly ever stop to think about it. And too often all we know about it is you plug it in and pull a switch. What is electricity and how does it work? Betty Brown's in trouble. Her lamp doesn't seem to light. How about it, Bobby? Can you help? Well, it would light, Betty, if you put the plug in the wall. That's where the electricity comes from, and you must have electricity to make the lamp work. But why, Betty wants to know. And that's where Bobby is stumped. Let's ask Dad. He usually knows how to explain things like this. Sure, Dad knows the answer. Bobby, get that little lamp from the workshop, and we'll go into the kitchen. And here in Dad's hand is something that will give us the electricity to light the lamp. It's called an electric cell. The two knobs you see at the top are called terminals. They are like doors to the cell. One terminal is for the electricity to come out, and the other terminal is for the electricity to go back in. But we know that electricity travels along wires. See, the lamp has two wires attached to the base. When the loose ends of the two wires are fastened to the terminals, electricity flows out through this terminal, along the wires, to the lamp, making it light. But Betty still wants to know what electricity is. What's in the wires? Well, electricity is made up of electrons. That's what's in the wire, Betty. Electrons. Electrons are tiny particles so small that we can't see them. But here's a drawing of the electric cell, the wires, and the lamp. And here show us what electrons would look like if we could see them. See, they might look something like this, always moving about. Even though one of the wires is not connected, the electrons keep moving about, but not going anywhere. But when the wire is connected to the terminal, the electrons start flowing in one direction. They flow along the wire to the lamp, where they make the lamp light up, pushes them out again. The cell doesn't make electrons, it just pushes them out as fast as it can. This movement around is called the flow of electrons, for that's what electricity is, Betty. The flow of electrons. And when electrons flow and light a bulb or run an electrical appliance, we have what is called a circuit, a closed circuit. This circuit is called a closed circuit because all the wires are connected and there are no loose ends unconnected. Only where we do have a closed circuit can the electrons flow out of the cell, down the wire, into the bulb, making it light up, and along the wire and back into the cell. Then they are forced out again and keep going around and around in the same path. When the circuit is broken at any point, the flow of electrons stops. So the light goes out when this wire is loose. It makes no difference where the circuit is broken. It can be here at this terminal, or here at this terminal, or any place at all in the entire circuit. As soon as the circuit is broken, the flow of electrons stops and the light goes out. As soon as the circuit is closed again, the flow of electrons starts and the light goes on. But Bobby has a question. What about the switch? When he pushes it, the light goes off. That means the circuit is broken. When he pushes it again, the light goes on. That means he has closed the circuit. But how? He hasn't touched any wires. The switch breaks the circuit for him, right here inside. A switch is just a simple way of breaking or closing a circuit. It saves the trouble of unfastening a wire every time we want the flow of electricity to stop, and of fastening the wire back every time we want the flow of electricity to start. Well, that's the first part of the story about electrons. Unless there are any other questions. Yes? Betty wants to know about the lamp cord. Why is there only one wire instead of two? In the circuit Dad just explained, there were two wires. One for the electrons to flow out from the cell, and another for the electrons to flow back into the cell. Aren't two wires absolutely necessary to light this kind of lamp? They certainly are, Betty. Without two wires, we can't have a closed circuit like this. But if you look closely at this small piece of lamp cord Dad is holding, you'll see that there are actually two wires inside it. One here and one here. A lamp cord is just two separate wires with a covering around them. Notice that the wires on all the electric cords you use around the house are covered. That's for protection. The electricity used at home is strong enough to give you a dangerous shock unless there is a covering or insulation around the metal wires to prevent them from touching you. Well, Betty and Bobby have found the answers to some of their questions. They have learned that an electric cell can give us electricity, and that electricity is made up of electrons, which are tiny particles always moving about. They've seen that when a wire is connected here, the cell pushes the electrons along the wire into the lamp, making it light up, along the other wire and into the cell again, where they are forced out once more to keep going round and around. This movement is called the flow of electrons. They know that when the circuit is broken at any point, the flow of electrons stops and the light goes out. They've seen that a switch is just a simple way of breaking or closing a circuit. They found out that there must be two wires in this kind of closed circuit. One for the electrons to flow from the cell to the lamp, and the other for the electrons to flow from the lamp back to the cell. And now there's just one more thing that's puzzling Bobby. Where is the electric cell in our house? Is it hidden in the wall? Do we have several of them? And when the cord is plugged into the socket, does it connect the wires with the cell? Well, Bobby, not exactly. There is no electric cell in the wall. The lamp gets its electricity from something different, but the idea is the same. There are just two more wires for us to learn about. The plug connects the lamp cord with the two wires in the wall, like this. The wires in the wall lead outside of the house, where they join a main line, which may be underneath city streets or overhead, until they reach a big powerhouse miles away. Inside the powerhouse is a generator, which, like the electric cell, can also provide electricity by pushing electrons out along the wires. But while the electrons that flow from an electric cell can light only a small lamp, a big generator can supply enough power or electricity to light many homes. So the next time you switch on the lamp in your living room, pause for a moment and think. Isn't it wonderful that we can control electricity and start it flowing over a circuit that may be many miles long to light a lamp or do any one of 1,000 tasks which make life simpler and more convenient for us? And we can do all this with just the click of a switch.